Testing. Hello friends. For this demo we will look at how a digital image is made up, and we will look at its components. In that process we will highlight certain aspects and features of the Nuke interface. This viewer window is where you're going to see the clips or the clip or the image that you are actually manipulating. We cannot see it right now because it is disconnected because of where it was saved and reopened from on different machines and locations. But an image would appear in this specific frame. You can navigate this frame by zooming in. To zoom in, you would just use the scroll on your mouse, the wheel. To zoom in, you can also hold Option, or if you're on Windows, you probably would use Control. Hold Option and middle mouse and zoom in and out. You can hold the middle mouse button to pan around. You can hold Option and the left mouse button to pan around as well. You do need the keyboard and all three mouse buttons and probably the mouse wheel to use Nuke. If this gets lost or disappears or gets out of whack, you can use the F key to reframe this back to the center. To view this full screen, you can hover inside the window and hit the space bar, and you can see it full screen. Nuke does not have a timeline, but it does have a play bar, so you can play a clip back. Nuke is not meant to be a video editor. It's better equipped to handle one very heavy shot or heavier shot. Alright, so down here this is the node graph where you would actually do the operating and controlling of your image and create functions through these, which are called nodes, and create filters and different kind of manipulation. The mouse controls and the keyboard controls work the same way in this window too. It depends on whichever one you're hovering over. So I can still use my middle mouse button to pan around. I can still use the wheel. I can still use F to reframe everything. It has this nice little window down here where you can navigate if your composite gets very big. It's not unexpected to have up to maybe 50 nodes for a moderate composite in this software. So I'll hit F again. I'm going to talk about these nodes a little bit. If you double click one of them, its parameters, the way that you control it, appears on the right. By default, you can see the last 10 that you clicked. If you click the next one, it just appears at the top and it goes down in order. This looks confusing, so I always change this number to 1. Maximum amount of panels. I move really fast, so I just want to click the one that I want to use and just use it. I don't need to see the other ones. It's up to you how many you'd like to keep in there. Let's talk about this clip that is not working right now because of the location where it was originally saved. I will bring in another one, fresh. That is by bringing in what is called a read node. Once again, these are nodes. You can see that it says read right here. It tells you what kind of node this is. This is a node. When I double click it, it has parameters. To bring in a read node, I would access this toolbar over here, which has categories of the different nodes that you can access. And these are pretty intuitive. If you want filters, you will go to the filters category. If you want to manipulate color, you will go to what is called the color category and choose a node from there. I want to bring in an image. Well, it's intuitive. There's an image category here, so I will read in that image, and then I can select and browse through my computer. Sometimes Nuke catches you off guard with the naming. If you are using an external hard drive, you probably need to go to where it says root and volumes. Then it will show your external hard drive, and you can go from there. For this material, all of the source files are always kept in a folder called source. Boom, there we go. Got it. That is not the only way to bring in nodes. You can also push the Tab key if you already know the name of the kind of node that you need, in this case, a read node. Oh, there it is popping up already. You can hit Tab and then type the name. Use the arrow key to navigate to it, or just use the mouse itself. Click it, and boom, it will bring up another one. So I'll click this and hit delete. Alright, so now you'll notice this path here in the parameters. You can actually click this little folder icon here and manually replace any files that don't work, or just change them if you want to use a different image. The other thing that is handy is when you have multiple files and you're moving between machines often, is that you can actually look at where the file path becomes the same. Take the part that is different, Command C to copy the new path, go to your file that's not working, highlight the part that is wrong, and paste to replace so that it's now the correct path. Hit enter, and boom, you can see that this is now working. But how do I get it to pop up in the viewer? It needs to be connected to the viewer node. In order to do that, you could manually go down here and drag it up. Boom, there it is. But what you would typically do is select your image or your clip and push the 1 key. Boom, and then it automatically connects it to the viewer. You'll see that there are other numbers. There's a number 2 over here. I'm going to do something really fast to make this image look different. Just put a color correct on it and just desaturate it or something. Okay, so for this one I hit the number 1. For this one I can hit the number 2. So now I can have more than one image connected to the viewer so that I can switch between them now. If I just hover in this section and push 1, 2, 1, 2, I can, for any reason, switch between viewing what I'm doing. So you might be over here testing something and you just want to check it. Or you might want to do a before-after of a color correction so you can clearly see your progress. And you can go up to probably as many as you want. And we'll get to why these look like this in a second. Alright, I'm going to rebuild this over here. This is just a pre-done demo. Here we go. Digital images. How are they made up? Well, if I hover over this image and move around, you'll see those red, green, and blue numbers moving up and down. That is because a digital image is made up of 3 or 4 channels. That is the red channel, the green channel, the blue channel, and I'll get to the other channel in a second. If I zoom in to the pixels and look at the individual pixels of the image, you'll notice that when I hover over any given pixel, those numbers change. If I hover only inside the pixel and move around, you'll see that the numbers are not changing. That is because the image is made up of red, green, and blue values per pixel on an individual pixel basis. And the way that it works is, I'm going to bounce over to some notes really quick. It is literally adding values, a unique value of red plus a unique value of green plus a unique value of blue to mix together to create the hue that you see here. And you'll notice that no matter where I move around, those red, green, and blue values never go beyond 1, they never go greater than 1, and they never go below 0. So we are mapping on a 0 to 1 scale for the minimum and maximum that you can go. You'll also notice that this concept is intuitive. So if I scroll over here to the more red parts of the image, you'll notice that in those 3 values, red is significantly higher than green and blue in those three values. If I go to the blue section, you'll see the same happens for blue. Yeah. Cool. All right. So now, I want to talk about the fourth channel, which is the alpha channel. The red, green, and blue determine the hue. The alpha channel determines transparency, which parts of your image are opaque or transparent. I'm going to demonstrate that concept by creating a rotopaint. You don't need to know about the rotopaint just yet. We'll get to that in a few weeks. But I'm going to draw a shape. This shape will determine which parts of the image are transparent or not. What I'm going to do is tell Nuke that I want this image to appear inside of this image. And you can see that this image is determining the opacity of this image. This is also done on a 0 to 1 scale. You'll see that if I hover in the white area, everything is maxed out at 1. If I go to the black area, you'll see that everything is maxed out at 0 or at the minimum of 0. So it's important to remember that white is always equivalent to a value of 1. Pure white. Pure black is always equivalent to a value of 0 in this mapping of digital image values. If I blur, hit tab, and blur my rotopaint, or my shape, by this number of pixels, you'll see that when I hover, now we are getting different numbers, a gradient of values until we get to 0, or until we get to 1. And that will be reflected in the image. So when I view the image, its opacity has that same exact gradient from going from 0 to 1. In the parts of the image that are pure white, the image will be fully visible, fully opaque. And in the parts of the image that are pure black, we will see nothing. I will jump over to the notes just to emphasize that 0, you can think to simplify it in plain English, 0 means no, I will not see my image. 1 means yes, I will see my image. If you want to think about 50% gray, 0.5, you can say that yes, I can kind of see my image. 0.8, yeah, you can mostly see the image. 0.3, not really. Okay, friends? And I would like to compare that to Photoshop, if people are used to using Photoshop. If I go over here we have layers, but over here we have channels, which you may or may not have used or accessed. You can see that it's possible to isolate each of these channels. You would not say that these are literally the channels, but they are black and white representations of the channels. And these representations, as I said, black and white, are mapped from 0 to 1. They're mapped from pure black to pure white. And as I said, white means yes, black means no. If I take, I'll just start with the red, because we always say red, green, blue, RGB. If you take the red channel and look at it, let's see. What this means is that in the white areas, the pure white areas, that means you have pure red. You have the most red. In the black areas, pure black, you have no red at all. First, we were talking about opacity and mapping these values of 0 to 1 to the concept of, or to the phenomenon of opacity. But in this case, we're talking about this mapping of 0 to 1 to talk about a specific channel, how much red there is in the channel. So once again, where there's black, there's no red. Where there's white, there's pure red. And if I go back to the original image, you can get a sense. Hold up. And it's the same for the green and the blue. I'll go to Nuke where that is easier to demonstrate, and right now you're going to see the advantage of node-based workflows versus layer-based. Layers are very hard to control, as you can see in Photoshop. But in Nuke, or in a node-based package like Nuke, it's very flexible. So more on the, I'm going to get rid of these. A little bit more on the interface. If I hover in the viewer window and hit the R key, I will see the black and white representation of the red channel, or the red channel. If I hit G, I'll see the green channel. If I hit B, I will see the blue channel. If I hit A, I'll see the alpha channel. There is no alpha channel right now. If I hit the same key again, it will go back to what we call the color channel. So I'll demonstrate that once more. I will hit B for the blue channel, and then I'll hit B again, and it goes back to the color channel. G, G, R, R. Okay? All right. So let's do this while let's look at this while we can see like the actual values. So I'll go to the R channel, the red channel, and I'll go to what looks like the pure white part of it. And what you'll notice is that in those three values that are changing, you'll see that it's wanting to get close to a value of 1 in the red channel for pure red. If I toggle back, we can see that we're in the warmer areas of the image. Cool. All right. So as I said, if I hit RGB, these are just representations of the red, green, and blue channel, mapped from 0 to 1. But how can I manipulate what we can think of as the red, green, and blue channel itself? I'm going to take a node called Shuffle, which reminds me, this is actually a newer version of the Shuffle. In Nuke, what you definitely want to do is go to the other tab, All Plugins, and hit Update. This allows you to access a whole bunch of extra nodes that are not accessible here. One of those nodes is another version of Shuffle, which is easier to use for our purposes. So we want to use this Shuffle node, not the other one. You are welcome to use both. Alright, so I want to connect this Shuffle node to my image. I can do that by just dragging this arrow, boom, and it's connected, and then from here I can hit the 1 key. Or if I select my image and then hit Tab, Shuffle, it is automatically connected, because when you put a node, when you drop a node down, it automatically connects to the last thing that was selected. If nothing is selected, it'll just be floating here, disconnected. You have to connect it yourself. Alrighty. In the Shuffle node, I can isolate the red channel. So this little diagram over here represents what channel you will see in each channel. Like it says in the name, Shuffle, it allows you to shuffle channels around. So for this, I will say, coming out of the red channel, I would like to see the red channel information. Coming out of the green channel, I would like to see not the green information, but the red information. Coming out of the blue channel, I would like to see not the blue channel, the blue information, but I would like to see the red channel, the red information. So I'm just going to say, basically what this says is that no matter what, if I hit RGB, and I'm pressing the keys right now, no matter what I push, I'm going to see the red information, because I want to isolate it. Right? So, and then what I'll do is, it's best practices to label this with R's. Over there it has 4 R's. Over here it has I have it named as a Shuffle I kept that name so that if you go back and look at this, you know what kind of node was used, and then I just changed the name to added some R's on it. I won't put 4 R's on it, I'll just put 1. Oops. By putting 4 R's, it reminds myself that I put red into all of the channels so that I'm only seeing the red channel information. So, boom, there's my isolated representation of the red channel. What I will do next is multiply this, double click it, and you see it's black and white. I'm going to go over to the multiply node and open up this number 4. This allows me to choose the color that I want to multiply it by, or color correct it by, using multiplication of those RGB values. Remember we talked about that red, green, and blue are literally added together to produce the color. I can take those numbers and multiply them. So I'm going to multiply them by pure red. Just going to put 0 in the other ones. If I have a value of 1 in the red channel and 0 in the others, that means what I have is pure red. So what I did, and you can see that how this changed, what I did was I took this black and white representation, multiplied it by pure red, and it gives me the red component of the original image. This will become much clearer later. Again, when you have a range of black and white, the lowest is 0, the highest is 1, and think about this. If you literally multiply 0 times red, you get nothing. 0 times anything is nothing. So that's why it's still black, even though I multiplied it by red. If you go to white, the white area, which means 1, if you multiply 1 times anything, you get itself. So in this case, I'm multiplying 1 times pure red, so I get pure red, I get itself, right? And that's the same way that the alpha channel works. Just to re-emphasize this a little bit. Just going to draw the shape again, our friend. I had emphasized earlier that 1 means yes, and black means 0 for plain English purposes, but really you're multiplying 1 times your image. If you get 1 times the image, you get the image. If you have 0, the black areas, if you have 0 multiplied by the image, you get nothing. Okay? And everything in between if you were to blur this shape once again. Cool. Just reiterating that. So over here we have isolated, once again, the representation of the red channel, used it as an image, but once I put this node on here, this black and white, this becomes a black and white image, basically a grayscale image. And I can do whatever I want with it. In this case, I'm multiplying it by red. So this, technically, is now the red channel. Just like if I were to go over here. And multiply this by red in Photoshop. There we go. Cool. And I bet you can guess what I'm going to do next. I will hit Tab, take another shuffle. I'm going to label it right away. G. Isolate the green information in the parameters. And I'm going to just view this. This is the green channel information. And I'm going to get another multiply node. And there are other ways to use the multiply node with wheels and whatnot. The more and more you use compositing in a technical way, the more you might like to type numbers in, because when you start clicking around on color wheels, it's a little bit arbitrary and becomes less and less intentional. Anyway, in this case, I want to multiply by pure green. Boom. So this image multiplied by pure green equals this image. Cool. Now remember I mentioned, and it's worthwhile to notice that you can branch off of any node any number of times so that you don't have to duplicate. You can duplicate a file and just do this again because it's just a file reference. You can do that for organizational purposes so you can see what you're doing. Like copy paste and then connect this here. It's the exact same, it would be the exact same thing, but only when you need, only if you have a lot going on is that useful. This again is not the file itself. Nuke is very lightweight. This is simply a reference to a file. Referencing that file only once is a good idea. Anyways. So remember, I mentioned that we add those RGB values together, literally. So I can do that with something called the merge node. The merge node is how you combine different layers together. So this is literally like layering in Photoshop. I'm going to double click this. Okay. And what you can do is connect it like this. It goes, the order of operations is A over B. And I'm gonna set the operation to, it's already defaulting to plus, but for the sake of demonstration, I will set this to where are you, my friend? I'll just do it like this, which I needed to demonstrate anyway. So I just put down a plus node. A plus node is a merge node. You'll see here that it still says merge. The reason that this says plus is because the operation here is set to plus, which I couldn't find earlier. But the default is to over. And over is just like when you put one layer over the other layer. Plus is when you add the values together. So what we're literally doing here is adding the red values with the green values, and what I get is this, which you could probably predict. If you take this image and add together, include only the red and green parts, what you get is this. And that would be reflected in Photoshop too, if I were to get rid of the blue channel here, deactivate the blue channel here. Okay. Very cool, and I bet you can guess what I'm going to do next. Oh, whoops. I'll do the shuffle node, call it blue. I'm going to isolate the blue information. Here is the blue information. And what I'm going to do is continue to build this tree downward. I will get a plus node, but you know what else you can do to speed up the way that these get connected? You can select one and then select the other one, hold shift, select one, hold shift, select the other one, hit tab, plus, boom, and it connects them in the order that you clicked them. So the first one that you clicked will go into the A input. The second one that you clicked will go into the B input. Whoops, forgot to multiply. As soon as you notice something's wrong, it's like pretty easy to identify what went wrong. Here we go. Boom, there we go. So what happened was I took the image components apart individually and literally added them back together to recreate this digital image. This is core to all of digital image manipulation and compositing and visual effects especially. I'm going to bounce back over to notes just to make sure we didn't miss anything. And no, we did not miss anything other than this concept of pure black and pure white is also used to talk about brightness and luminance and exposure in general, if you're thinking about photography and cinematography. Thank you very much.